Math and Navigation, presented for Oakland City University Math 570 History of Mathematics, under the direction of Dr. Amy Barrett. Today we're going to give, first off, a brief history of marine navigation. Since the construction of the first boat, people all over the world have set sail on adventures. However, sailing the high seas was a dangerous event. In fact, captains and sailors across the world rarely traveled out of sight of land for fear of being lost at sea. There are several reasons for this, many of which were limited tools and limited knowledge. So the study of navigational concepts became essential. The advancement in four fields, however, began to help out and advance the knowledge of navigation. Those four fields were instrumentation, the creation, the invention of different tools to help guide; astronomy, understanding the stars, understanding how the earth worked, using the fact that constants such as the sun, the moon, the stars in the sky could be beacons to help them guide them. Sailing, general advancements in understanding knowledge of how to sail, the building of better boats, the understanding of sails and masts, all of that also helped. And finally, the focus of this presentation, mathematics. The first part of navigation that math helped push along was the math of location. Latitude. Latitude was studied to improve the north-south location accuracy. The way they went about this was quite ingenious. They used angles between sun and the horizon in the daytime, and they used the height of the North Star at night. Applying geometry and trigonometry concepts to these calculations, they could determine their relation to the equator and therefore hold a bearing the same from day to day and put them on a straight path that they could repeat and notate for future trips. Another byproduct of this study of latitude was the earliest maps. Understanding the idea of the globe, understanding the idea of latitude increased navigational accuracy and success because they were able to pass this information down to other explorers from generation to generation. Also, what helped the math of location in studying of latitude were multiple devices. Circa the 15th century, the first one was the quadrant, as seen to the side. It was a simple device to measure the angle between the sun and the horizon. The next advancement was the astrolabe, the cross staff, and the backstaff, which basically performed the same job as the quadrant, a measuring of angles that could be recorded. Now, whereas the north-south location of latitude could be calculated fairly easy over time using the tools shown before, longitude, which would be the study of east-west location, took a little bit longer. It proved to be much more difficult, due first of all to the lack of instruments to measure. One of the first processes of measuring longitude was dead reckoning. Dead reckoning was a very crude method that involved using a fixed position and recording heading, speed, and time to determine a final position. This concept included some mathematical concepts such as vectors, but as I said, with the tools and the understanding of speed and time and things of that sort, this was not a very easy or clear understanding. In fact, it began a worldwide problem that needed to be solved, and actually, as you'll see later, led to the invention of what's called the chronometer. All right, the next concept that needed to be solved with mathematics was the mathematics of speed. Understanding how fast the boat was going, how long it took them to get between places, was going to be a very useful and practical tool for captains. The first one we're going to look at were called chip logs, which were crude speedometers. The sailors would knot lines at regular intervals. Then one sailor would toss the line overboard and count the number of knots let over a specific amount of time. What this allowed the sailors to calculate was speed. They could say that we traveled 15 knots in 1 minute, and therefore they would come up with a unit of time, which they then called knots, and we still today called knots. This was one of the more interesting things. I never really understood what knots meant. Now I do. It was a crude, early way to measure speed. Of course, time is an important concept when it comes to speed. And in the 15th, 16th centuries, there were no clocks. They had hourglasses, they had sundials, but they didn't have a working, accurate clock. So east-west location required an accurate measure of the time for speed calculation, as I said before. And early methods for time measurement included sundials and constellations at night. The problem became so great, as I said earlier, about calculating longitude, that there were countries who offered prizes for a time measuring device. And the man who devoted his whole life to this is John Harrison. He is credited for the invention of the chronometer. As you've seen, math was an integral part in navigation. And navigation was an integral motivation for the study of mathematics, which makes their connections unmistakable. The advancement of math allowed opportunity for growth in navigational knowledge. The need for navigational knowledge drove the advancement of mathematics. So this search for new knowledge and understanding led to discoveries that changed and shaped the world we know forever. Math and navigation were forever connected.